Hello and welcome back to another video. In this problem, we're asked to prove this statement using the precise definition of a limit. The limit as x approaches negative 1.5 of 9 minus 4x squared over 3 plus 2x is equal to 6. So before we actually go ahead with the precise definition of a limit, it's going to be helpful to simplify this function. So we have the limit as x approaches negative 1.5 of 9, we're going to write as 3 squared, 4 as 2 squared, and x as x squared. So this is 3 squared minus 2 squared times x squared over 3 plus 2x is equal to 6. Therefore, this is the limit as x approaches negative 1.5 of 3 squared minus 2x squared over 3 plus 2x. This is therefore equal to the, on the numerator, the difference of two squares. So we can say that this is equal to 3 plus 2x times 3 minus 2x. And this is over 3 plus 2x. And therefore we can say that these two things cancel, and this is simply equal to the limit as x approaches negative 1.5 of 3 minus 2x, and that this is equal to 6. So when we're eliminating this, you might be worried that this can no longer equal 0, right? Or it could always never equal 0 because it's in the denominator of the fraction and you can't divide by 0. And by eliminating this, normally that's a cause for concern because you can't just eliminate a domain restriction. However, if we solve for x here and see the value that it can't be, we can see that x is not equal to negative 3 over 2 or negative 1.5. So x can't be that value. However, this is the limit as x approaches negative 1.5, so it doesn't even matter that we can't have that value because we're only looking at the numbers that are getting closer to it, not actually at it. So we can therefore say that this is the simplified version of the limit, and we can use the definition of the limit, which states that the limit as x approaches a of f of x equals L if for every number, every positive number epsilon that you could choose, there is an associated delta that is also positive, such that if 0 is less than the absolute value of x minus a is less than delta, if this is true, then f of x minus L is less than epsilon, right? For every epsilon, there's going to be an associated delta for which this relationship is true. So we have to find that and say, okay, we have 0 is less than the absolute value of x minus a. A is the value which x is approaching, right? So therefore a is negative 1.5. And f of x is the function, which we're saying in its simplified form is 3 minus 2x. Delta is 6, and this is less than epsilon. Therefore we have 0 is less than the absolute value of x plus 1.5 is less than delta, and negative 2x plus 3 minus 6 is minus 3 is less than epsilon. So to get a relationship between delta and epsilon, what we need to do is get these inequalities to match. And currently this is a double inequality, this is a single inequality. So what we have to do is we have to get rid of this part. If we're saying that the absolute value, I'll write it up here, the absolute value of x plus 1.5 is greater than 0, right? If that's true, then we can say that this is only telling us that x plus 1.5 is not equal to 0, because the implied part of this is that it's not equal to 0 and it's not equal to any of the negative numbers if it is greater than 0. However, we knew it's already not equal to any of the negative numbers because it's an absolute value. If we solve this, we say that therefore this restriction is only telling us that x is not equal to negative 1.5. We already knew that this is not a problem from earlier, so we can just eliminate this. Therefore, we're only saying that x plus 1.5, the absolute value of this is less than delta. We need to relate this to this inequality. So what we can do is we can factor out a negative 2. So this is the absolute value of negative 2 times x, and dividing negative 3 by negative 2 is 1.5. Probably see where this is going. Factoring out a negative 2, it becomes positive 2 because we took the absolute value of it. 2 times x plus 1.5 is less than epsilon, dividing by 2. With the absolute value of x plus 1.5 is less than epsilon over 2. this absolute value is less than delta, it's less than epsilon over 2. Therefore, we can say that delta equals epsilon over 2. And to prove this, what we have to do is take, okay, if we have this relationship right here, if x plus 1.5 is less than delta, it's also less than epsilon over 2. If we multiply both sides by 2, we get 2x plus 2 times 1.5 is 3 is less than epsilon. If we multiply both sides by the absolute value of negative 1, absolute value of negative 1 is just 1, so this is epsilon times 1 is just epsilon. But if we factor it into the absolute value, we get negative 2x minus 3 is less than epsilon. This is therefore saying that negative 2x, negative 3, we're going to split into plus 3 and minus 6 is less than epsilon. And this is equal to f of x in its simplest form. F of x minus 6 is minus L is less than epsilon. Therefore, we can say, given this relationship, we just proved that absolute value of f of x minus L is less than epsilon. And it might just look like we just undid what we did to find it. But what we're proving here is that if we know that for any epsilon, we can just divide it by 2 and get a delta, we therefore prove that if we use this delta, that we know that the absolute value of f of x minus L is less than epsilon, which is the actual definition of the limit.